Now, in this diagram here, we have this angle here, B, and call that angle there. C, we have C1, C2, and this one is A. We have D. Now, we say angle C2 is equal to, let's write it here. Angle C2 is equal to angle A plus angle B, the sum of A and B equal to C2. And the reason is that it's an exterior angle of a triangle is equal to the interior opposite angle. Is equal to the interior to the sum of the interior angles of a triangle. Now, let's have a look at this triangle here. And then let's label this X, Y, and Z here. Angle Y will equal to angle Z here. And the reason is that that triangle is isosceles. Isosceles triangle. Now, if we extend this line up here, I hope you will appreciate that at X there, we have two angles, if not three. We have this angle which is outside of the triangle. And we know that from the previous encounter with triangle ABC, this angle here will equal to that angle there plus that angle there, which we have here. That will be exterior angle is equal to the sum of the two interior opposite angles. That's what we have. Now I want us to extend this knowledge of isosceles and the exterior angle and look at figures in a circle. We are going to have a circle. We are going to have a circle. And in this circle here, we are going to have lines. And we are going to label let's have another one here. Going through that angle there. this angle here. Let's call that A, call that B, call that O, call that C. And if O is the center of a circle, if O is the center of a circle, we will appreciate that BO and AO will be the radius in that figure. So AO, because O is the center, will equal to BO, which will equal to OC. And the reason is that that's a radi. Now, we have two triangles here, triangle ABO and triangle OAOC. Now, we said, let's label this x1, that 2, O1, O2, O1 and O2 will give you this angle here, which is angle BOC. Angle BOC, the sum of angle 1 and angle 2. Now in triangle A, BO, angle O1 is equal to angle A1 plus angle B. And the reason is that O1 is outside the triangle. It is an exterior angle of a triangle. Exterior angle is equal to the sum of the two interior opposite angles. Now, we know that, angle A1 is equal to angle B. The reason being, a triangle ABO is an isosceles triangle. Isosceles. An isosceles triangle have the base angles which are equal. Isosceles triangle. The base angles of an isosceles are equal. This angle is equal to that angle because BO is equal to AO, isosceles triangle. Therefore, we can write this statement here in terms of angle O1 is equal to A1, you can write B because they are equal. Or we can write A in terms of B, they are equal. Where I see A1, for B here, I'm going to write A1. Now, that adds up to 2, well, A1. Similarly, we can use the above argument to show that angle O2 is equal to twice angle A2. The same reason that angle A2 is equal to angle C, reason isosceles. Again, in triangle AOC, angle O2 is outside a triangle, so it's equal to A2 and angle C. Exterior angle of a triangle, the sum of the two co-interior opposite angles of a triangle. Now let's see what happens if I combine A1 and A2. Which is A2 here, that's A1. I will have twice angle A1 plus twice angle A2 is equal to angle O1 plus angle O2. But O1 and O2 gives us angle BOC. And angle BOC is at the center of a circle. This is equal to 2 is common here. We take 2 out because 2 is common. It's a common factor. I'll take A1 and A2. There's the bracket. There's the bracket. A1 and A2 forms angle A. Therefore, the angle at the center of a circle is twice the angle at the circumference. The circumference, this is the circumference of a circle. That's the circumference of a circle. So we can conclude that twice the angular circumference is equal to the angular center, or the angle at the center, the angle at the center of a circle is twice the angle at the circumference. Or you can say angle BOC is equal to twice angle A. Let's see what happens on both sides if I multiply here by the reciprocal of 2. So, which says half the angle at the center is equal to the angle at the circumference. Half the angle at the center is equal to the angle at the circumference. So what do you have? Now let's see what you mean. We mean that if this angle here is 120 degrees, the whole of this angle here will be half of 120, which is 60. So it means, let's look at an exercise, 102 of the exercises. But before we look at that, let's go to the diagrams that explains one and the same thing we have here. That the angle at the center of a circle is twice the angular circumference. And the diagrams that you mostly get in exercises go this way. You will have something like this. You have that. And that. And that. And that. Now in this figure here, on that circle, you will have this angle here will be twice this angle here. So if this angle is 240 degrees, this will be 120 degrees. This is 240 degrees, this will be 120. Because this one is the angle at the center of a circle, that will be the angle at the center of a circle. Circle center O. There. Let's look at the other one that you will get. Same family. Same family. Is that you have this. Have that. You have that. This angle here is twice that angle there. So if this angle is 40, this one will also be 20 degrees. If that angle is 40, this one will be 20 degrees. So the angular center is twice the angular circumference. That's what you have. We can have a look at 102. Let's take this one as an exercise. Let's take this one as an exercise. That's a diameter. It goes through the center of a sector. That's the diameter. It goes through the center of a circle. That's the diameter. It goes through the center of a circle. This one comes here. And let's see what we know here. If that line passes through the center of a circle, let's label it A, B, C, O. It means this AO is equals to CO. It's the same as BO. Now, we are given that the magnitude of this angle is 39 degrees. And we are required to find for theta here and alpha there. Now, in triangle BCO, angle C is equal to angle B, meaning this angle here is equal to this angle here, and the reason is isosceles triangle. Therefore, this will also be 39, but alpha is outside the triangle BCO. Therefore, alpha will be twice 39 degrees, or simply we say alpha is equal to angle C plus angle B. Let's call that B1 for clarity. We'll call that B2. That, and the reason here is that exterior angle of a triangle, but we know that on top there, angle C is equal to B, so C is 39, B will also be 39, we found that by isosceles. This is 78 degrees, so alpha will be 78 degrees. Alpha will be 78 degrees there. Now, if alpha is 78 in triangle ABO, BO is equal to AO, which also means that these two angles are equal. This must also be alpha, theta. This one is alpha, that one is theta. Because BO is equal to AO, it makes this triangle isosceles. Therefore, two ways of doing it. If I add alpha to alpha, theta to theta, and 78, it must give you 180. Also, this angle here is equal to that angle plus this angle. The choice is mine. As I can see, this angle here is 180 minus 78, which gives you 102. Or I can say 2 alpha is equal to 102 degrees, and the reason is exterior angle. Therefore, theta will equal to 102 degrees divided by 2, and that will be 51 degrees. Therefore, theta is 51 degrees. One root. The other root, I can use the sum of the angles of a triangle. I can say angle A plus B1 plus B2 plus alpha equal to 180. Reason angles of a triangle. I know what alpha is. I also know that sorry, angle A and B2 are equal. So I can write theta here. I can write theta at B2. I can write theta at B2 and at A. I can write theta for A. I can write theta for B2. So 2 theta is equal to 180 minus 78 degrees. This is 102. Now this statement here is the same as the statement there. So there always more of a time, more than one way of solving these problems. Hope you enjoy.